Welcome to another video. Today we're gonna discover the Mandelbrot set and more specifically some extensions on it. Well, let's start with the first picture. This is the well-known Mandelbrot set. So how is this picture generated? Basically, you start with a number, let's say 0, and let's say C, the constant is 0 in this case. Then that's going to be the new zn plus 1 value. So then 0 is zn plus 1. Then you square that. So that's the zn squared. That will give again 0. Then you add the 0 to it, etc. etc. As you can see with 0, this clearly keeps being a 0. But if I, for instance, take 2, if I start with C is 2, and if I make zn plus 1 equal to 2, then the zn becomes 2, then I have to square that, so that's 4, plus again the constant 2, that's going to be 6. So zn plus 1 is going to be 6, so I have to square that, 36, plus 2 is 38, etc. So what you see, that depending on the starting value of the C, the number either diverges to infinity or minus infinity, or it converts to something like 0 or something below 1. And depending on that condition, does the number go to infinity or not, we can make colors, we can give colors. So how come I then get a 2D picture? Because in this picture you can see a 2D result of the Mandelbrot. Well, actually the C we can take a complex number. So we can take a real part and an imaginary part, and then we get two x's where we actually can, for each point, determine does it go to infinity or not, and how quickly. Okay, so what I experimented with in this video is that square function. So here you see zn squared, and it's a little bit strange because you see 2.0, and that's already a little bit spoiler alert. I thought, hey, what's gonna happen if I don't put 2, or for instance, but like something like 0.03. Well, that's kind of boring. Here you see the result. And then I was thinking, okay, but what's gonna happen if I increase that exponent and see what the result is giving? Well, let's see what's happening. Now it slowly goes bigger, and we're getting pretty close now to the 2, so then you will recognize the famous Mandelbrot results. But now something quite interesting is happening when it gets bigger and bigger, the exponent. And I didn't expect this, but it seems that there's some kind of a symmetry, and the symmetry, like this looks like a 5-fold symmetry, and now it's like 6-fold, and it depends on the exponent. And when I think about it, I think it's logical, but I did not expect it at all. So yeah, in my mind this is really pretty cool. Unexpected result. And it's nice that we have computers and that we can do this kind of stuff with such a speed, because making this code was like, I don't know, half an hour, almost no work. So pretty cool. I'm just gonna watch in silence and admire what's happening. Okay, not totally silence. What you see is also that the number of spikes on the, let's see if I can show it here, these spikes are all the time increasing as well. So that's really quite intricate things going on. I would actually love to spend much more time on this, but probably not gonna do it. Pretty cool. Running this kind of code takes like I don't know, a couple of hours, and it produces all those little pictures, and then I make a movie out of those little pictures. And this is almost the end. I think I went to something like 30, I think. Something. I'm not sure anymore. Pretty cool. Okay, thank you for watching, and have fun with math and modeling and simulation and artificial intelligence and blah 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 blah. Science is awesome.